Hi everybody in YouTube land, Scott here. That's a battery charger on the wall, and there's the whole setup that you've seen before, the Gigantower thing. There's the sending coil, and I'm outside in the dark, and here's the receiving coil, and this is the side that's open right now. The whole setup. Alright, I will go through the whole works here. Okay, it's dark, but homing in on it here, I have a bank of batteries that are just 12-volt lawnmower batteries. They're connected to that light that came from a lawnmower. There's another one just to have utility lighting. So there's the bank of batteries. So off the bank of batteries is the lights. To this little starter motor right here with a pulley on it adapted. This is a starter off of a lawnmower. And 3, the primary transformer to the whole setup. Now the motor that you just saw turns this wheel with a big contact on it that rides on a cam. I'll get a light. Alright, I think in the background now you can see near the top the motor with the pulley I just made reference to. Now that, through this long dryer belt, runs this big compressor pulley, which is mounted to a regular motor that has the stator removed and these little bars welded on it. And so, the risk of losing some light, you'll see if I just spin this wheel here, this thing pilots that cam up and down, and that runs a set of contacts which completes the third part of the 12 volts, which goes through this hair dryer resistor and into the oil vatted microwave oven transformers. Now, real quickly, before I go through that, here's what I do to change the speed on this whole piloting sequence. Alright, no laughing, but to change the speed, this is the dryer element. An element out of a dryer, clothes dryer. And all I do is connect up some sections of that to vary the speed to that motor. Alright, so as that starter, driven through the variable speed coils you just saw, pilots this motor device with a contact on it, that throws 12 volts from the battery bank through that resistor into these, which are 2 microwave oven transformers that have the primaries removed, and I have number 12 solid THHN regular conduit wire running around about 10 times on each one. Then they're submerged in oil. And a fine detail for those into this, the back side of the secondary on the second transformer has been unisolated, or no, it's been isolated from ground and tied to the front side of the first one. So I'm getting the secondaries in series. The primaries are in parallel. Gets pretty good snap, and that goes out to, where does it go? Oh, it goes into my capacitor bank, which I'll show now. Alright, my capacitor bank consists of this big bucket, which is one of a kind, 2, 3, 4, 5. So 4 encyclopedia capacitors and one big bulky bucket. They're all 5 are in parallel. Those 2 microwave oven transformers feed both of those banks, both sides of the capacitors. And one side is all grounded, the secondary of the big coil, the primary of the big coil, the negative side of the MOTS, and one side of all the capacitors is all grounded as in Tesla's 1119732 patent because of safety, plus it's just easier delivery, pulse, and so forth. Alright, on to the next thing. Alright, on to the next and hopefully last part of the sequence is the spark gap modified apparatus with the air valve quenching method. And I got some floor tiles because I didn't know how bad it was going to be. It doesn't shoot very far, but anyway, the air is to blow across the little adjustable spark gaps there, and basically the MOTS feed the 5 capacitors, and then the output of the one hot side of the capacitor side that's not grounded goes into the spark gap and then out, up, and into the primary. And then all the stuff happens, and this is all I have for top load, and this is number 12, THHN, again, recycled wire, so I don't have a lot of resonance, but here I'll show you what I've got without the air on, at night, in the dark, with it cold. Alright, Cutler hammer, 3-phase breaker, all wired in parallel. 20 amps seems to handle the 12 volts through a car battery into the primaries I got that are almost dead shorts, and it seems to protect it. Alright, here's how I start this thing with this big piece of metal that goes right on there. And I can vary the speed way slow or here. Alright, here goes the breaker. Alright, and I don't know if you guys can see much of that breakout. Yeah, you can. So, that's about what I've got right now without the air gap going. You know, it's about a 2-3 inch gap. 2.5 inch. Alright, I'll put the air on and see what happens. You can see the little breakouts trying vaguely in the dark. There's the receiving coil. Free air. Actually, the ground is connected to the secondary. And of course, it's so close it better be lighting. Alright. I'll turn the compressor on. Alright, got it going again. There's the spark gap. And I'll open the valve a little bit. That makes quite a difference on the little tendrils, as you can see now. They're brighten right up. That makes quite a difference in the length of the arc. A good 1.5 inches extra anyway. That's probably 4 inches right there. It doesn't seem to be knocking this one out too bad, but it's probably just so close. Anyway, there's the little hair sticking out, all because of the air gap. I'm getting a little breakout down here. Over and out.